Hello, guys. Hope you all are doing well. Today, I am here with you with another interesting topic, and this is what is a wave? If you are among those who are confused with this topic, then no worries. We are going to learn the basic concepts and properties of waves in this video. We will be further discussing the concepts about traveling waves and how to calculate the velocity of a traveling wave. Similarly, we will be focusing on a graphing and plotting the wave. In our previous video, we have highlighted the role of waves in our daily life. If you haven't watched that video, you can watch this video from the above link. Now let's start our discussion about wave. What is a wave? Wave is defined as disturbance in any medium. Let's have a look at this traveling wave. You can see the blue marker is oscillating up and down, and as a result a wave is generated, and this disturbance travels from left to right. You can consider this blue line as a string, and this wave is being generated in a string. Let's have a still snapshot of this traveling wave. We can see humps and dips in this wave. In literature, these humps are termed as crusts and dips are termed as trough. The center line is the undisturbed position of the wave. Now let's discuss some properties of the wave. Firstly, the wavelength. The distance of any point on the wave from its next exactly similar point is termed as wavelength. For example, the distance between blue and red marker is one wavelength. Similarly, distance between two consecutive crusts or troughs is a wavelength. Secondly, let's discuss about displacement. It is the distance of a point from its undisturbed position. You can see we can define displacement like this. The third important property is the amplitude. It is the maximum displacement from undisturbed position. You can have a look at the graph. Hope so. Now you can understand these three concepts. Let's jump on to the further details. Again, consider a traveling wave and let's define its time period. It is the time required for one complete oscillation of a wave. For example, you can see the blue pointer in the graph is oscillating. The time in which it will complete its one oscillation is termed as one time period. Let's have a look at frequency of a wave. It is the reciprocal of time period. It is oscillation per second, or you can say number of waves passing through a point in 1 second. You can see the fixed point P on the graph, and wave is moving towards right and passing through that point P. By looking at the time clock on top right corner, you can see that only one wave is passing through the point P in 1 second. Hence, velocity of the wave is 1 Hz and the time period is 1 second. Well done. Now let's come to your most favorite equation, and that is velocity equals to distance over time. If distance traveled is equal to one wavelength, then the time period will be one time period. And from our previous discussion, we know that 1 hour time period is actually the frequency. So the equation becomes V equals to F lambda. This is a very handy equation which is actually relating the velocity of the wave, frequency, and its wavelength. Now let's have a look at the practical implication of this equation. Using this relation for the traveling wave, we can easily find the velocity of the wave. For example, this wave has the frequency of 1 Hz and the wavelength of 1 meters. Putting those values in the equation, you will get the velocity equals to 1 meters per second. Now, what happens if we increase the frequency? Take a moment and think. Yes, you're right. By increasing frequency, the velocity have actually increased. We have increased the velocity 5 times and the frequency have increased by 5 times. Well, hope so. Everything is clear till here.